Okay, now we are going to see how we can, provide the seismic definition and seismic load cases. Okay, so to do that, first of all, we have to go this seismic definition. Okay, seismic definition we have already assigned, but we have not put any value here. Okay, so now we will put value here as we are modeling our, shade, considering, ASC 705. Okay, so we will keep that here. Okay, then we will make all this, zero. Okay, we will make all this zero. Okay, okay. Now we have four specific value. Okay, we have four specific value: SS, S1, FA, and FB. Okay, so what are the value? So first of all, this is S1. Okay, this is sorry, this is SS, this is S1, this is FA, and this is FB. Okay, so these are the value as we are modeling as per ASC 705 and BNBC 2020. Okay, so if I consider this code, okay, then we can get this value. Then we can get this value from, AC, okay, hazard tool, or USGS, okay, design web services. Okay, the main focus is that, this tool, this website, if you provide the latitude and longitude of any place, then it will give the value of SS and S1. Okay, and from table of ASC 705, you can get FA and FB in case of ASC 705. But in case of BNBC 2020, we have a specific table at the end of the code. You can go to Appendix C. Okay, Appendix C, Part 6. Appendix C, Part 6. Here you can see, okay, there is a value explicitly given for the seismic zone, and soil type. What you have to do, you just have to find out the seismic zone and soil type, actually the soil class, and take the value and put at the model. Okay, similarly you can find SS, S1, FA and FB value from your hazard tool or USGS design web services. Okay, so for this model, we just consider SS equal to 0.5, S1 equal to 0.2, FA equal to 1.35, okay, 1.35, and FV equal to 2.7. Okay, so these are the value we are gonna put, okay, in our stat model. Okay, now what we are going to do, we are going to the model. Okay, we are going to the model. These are so first of all, S1 is 0.5. okay, 0.5, okay, and 0.2. okay, keep TL 12, no problem. F1, FA, sorry, 1.35, and FV equal to 2.7. Okay, 2.7. Okay, let us consider the building have a importance factor of 1, and here is the response modification factor, that is the value of R. Okay, look here, along x direction, there is only frame. Okay, there is only frame. So this is a moment resisting frame. So we consider it as an ordinary moment resisting frame. If we go to ASC 705 or BNBC 2020, we will find like this one. Okay, if you go moment resisting frame, here you can see ordinary moment resisting frame. This is from ASC 705, which is same as BNBC 2020. Okay, so for ordinary moment resisting frame, we have a value of R equal to 3.5. This is the value of R. Okay, okay. Then other direction, you can see, and on other direction, the lateral load is transferred by the bracing. Here you can see the bracing. Okay, so if I go to that table again, here you can see that here you can see that so here you can see on the other direction, let us consider the building is, the building is ordinary steel concentrically braced frame. Okay, in this case, the value is 3.25. Okay, this is the value of R. So at the one direction, we have 3.5. On the other direction, we have 3.25. Then we go to the model, then put along x direction, it is 3.5, but on the other direction, it is 3.25. Okay, so let us consider the site class of this building, of this project. Okay, 4 SD, no problem. Okay, then we have put those value, and then we need to calculate the value of CT. Okay, to find out the value of CT, we first need to find out the the framing system. The framing system will tell us what will be the value of CT. If I go to that this table, here you can see this is taken from ASC code, ASC code. Okay, this ASC code, here you can see CT value. It depends on framing system. First of all, steel moment resisting frame, and then concrete moment resisting frame, and then eccentrically braced steel frame, and then all other frames. Okay, so here we can see for our building, at one direction we have steel moment resisting frame. Okay, that is along x direction. If I go to the model, if you can see here along x direction, it is an ordinary moment resisting frame. Okay, so we can get the value. We can get the value from here. Here we have two values, this one and this one. This one for FPS unit, okay, and this one for metric unit. Okay, this one. Okay. Now, on the other side, we have a ordinary steel. Sorry, on the other side, we have a ordinary steel concentrically braced frame. Okay, so if we go to the table, we can see we don't have any steel concentrically braced frame here. So that criteria will go under this one. Okay, under this one. So for other direction, T value will be like, CT value will be this or this. And from this value, we have to calculate the value of T. So the equation of T equal to like this way. T equal to CT, okay, HN, height of the building, to the power X. Okay, so CT equal to, for as we are modeling in SI unit or metric unit, So we will use this value, okay? We will use this value 0.082, 0.082, okay, 0.082. Another one is 0.08, 0.0488, okay? Sorry, 0.0724, okay? The first of one is 0.0724. So 0.0724, okay? 24 into height of the building. So what is the height of the building? Let's go to the model. If I click here, okay, any of the top point, if I click here, at the double click at the any point, we can see the total height of the building is 9.780. Okay, so take this value. So take this value here. So 9.780 to the power 0.8 x. So how we are getting the x? Here is the x. Okay, for this it is 0.8, but on the other direction we have 0.0488. Okay, 0.0488. Then again 0.488 to the power height will be the same, 780 to the power 0.75. Okay, so we have two framing system on two sides. So we have taken two values of t. Here is another one, here is another one. Okay, so what is the height? Let me check once again. This is 80. Okay, okay. Then we calculate from here. So 0.0724 into 9.780 to the power 0.8. Okay, so this gives a value of 0.45 second. Okay, and this one gives 0.0488 to the power 0.04889 into 780 to the power 0.75. Okay, so the value is 0.27 second. Okay, so this is the value we are getting from from the calculation of t. Okay, on calculation of t. So we have two values for two direction, 0.45 second and 0.27 second. So we will use this value lower one. Okay, lower one. Okay, as you can see in Stadd there is only we can use both, no problem. We can use both, no problem. So if I keep 0.0488, okay, doesn't matter. Along x direction, what is your t value? Your t value is 0.45. On other direction 0.27. Okay, so if I go to 0.45 and this time we'll go 0.27. Okay, 27. Here this is called x. So you can put any one of the x, no problem. Okay, so actually model will take this t value. Okay, this t value from here as you have calculated and provided here. So model will take this 0.45 and 0.27. Model will not take anything from 0.4088 or 0.8. Okay, so this is this is how to put your data okay, for for the seismic definition, then change. Okay, then it has been changed here. Okay, then close it. Okay, so this is how you can put the seismic definition. Okay, now what we have to do now, then we have to go to the load case, select EX, then add. Okay, then add, and then you have to go seismic load, X direction. Okay, fine, add. Okay, and then you go to this direction, negative X direction, and then again seismic load, but this time with a negative sign. Okay, add. Again, go to this one, add, okay, then again go to seismic load, then Z direction, positive, okay, again go to this one, add this one, seismic load Z direction, but this time with negative minus, okay, then add this one, okay, okay, I want to save it now, yes, yes, okay, okay, so our load case has been done. Okay, so there is another thing you have to do here. Okay, so what is the thing? Look, uh, for seismic loading, we know that base shear V equal to CSW. Okay, this is as per AC 705. Okay, 705, and V equal to 2 by 3 ZICSW over R. This is as per BNBC 2020. Okay, so software will calculate this W. Okay, but you have to make him to calculate this W. And how you will do this one? Now I will understand you. So this W is, what is this? This is called effective seismic weight. Okay, this is called effective seismic weight. Okay, so now we go to the model again. This is a shortcut. I will tell you how to put this value for software to calculate the seismic weight. Actually, wait. So go to edit input data. Okay, simple. Edit simple data, then go to here you go. Look, here you go to here, you can see load 5. This is your dead load. Okay, this is your dead load. Now let's go to here again. Sorry, just close it, no problem. Here you can see seismic weight. Okay, this is as per SC 7705, and this one is BNBC 2020. Okay, so what ASC says, you can check it from here. Okay, ASC says only 20% of your live load should be assigned if it is a storage area. Okay, if it is a storage area, and full load if it is a permanent equipment. But what happened in case of BNBC seismic weight? BNBC have a slab, okay, based on the live load. What BNBC says? BNBC says if the live load is less than or equal to 3 kilonewton, then 25% of the live load should be added. Okay, if it is more than 3 kilonewton, then 50% live load should be added. If it is a permanent or heavy equipment, then 100% load should be added. So if I then again I go to the model, go to edit, edit the command line, okay, and here you can see here is a dead load. Okay, so you just copy this self weight and all other dead load. Okay, dead load, copy it, and then go to, you can see here, you define IBC code. This is ASC 705, and you have input those data previously. Then click at here and then a space. Okay, and then Control V. Okay, then you can put it back here. So what you have to do, you just have to delete all the negative sign and the direction. Okay, and load will be replaced by weight. WEIGHT, weight. Okay, and all the negative sign will be deleted, including the direction. Okay, here you can see including the direction. Okay, negative sign and including the direction. Okay, So software will automatically calculate W from your dead load. Okay. But if I follow ASC 705, then it is okay. Okay, because what ASC 705 says, if you have a storage area, then 25% of live load should be added with dead load. Okay. So we don't have any storage, okay, here. So if I follow BNBC 2020, then what we'll have to do? We will have to also copy, we will have to also copy this live load too, okay? This live load too, if we follow BNBC 2020. Then click here and then enter and then paste. Then what we have to do, we have to replace load with weight, WIGHT. We are doing it by BNBC 2020, okay? BNBC 2020 says if our live load is less than 3 kilonewton, then 25% of load should be added. Here our live load is 1 kilonewton per meter square. So it is less than 3 kilonewton per meter square. So 25% of the live load will be added with dead load, okay? So this is our live load. So first of all, we just delete the minus sign and the direction. Similar case is here, okay? Okay. Now we will take only the 25% of 6.1 and 25% of 3.05. So 25% of 6.1 equal to 1 point equal to what is the value? 1.525, okay? 1.525. And for 3.05, what is the value? 25%, 0.76. Okay. 7. Clear? Okay. So this is how we can put, as per BNBC 2020. Or if you are modeling with ASC 705, then you don't need this one, because ASC 705, okay, says only if you have a storage, then 25% of load should be added with dead load. Okay, so we are considering here as a BNBC 2020. So we are keeping it here. Okay, one thing you have to do here, you can do it here. Okay, you can see your load case load number 1, your seismic wave, IBC load X1. So you can put a enter. Okay, you can write perform analysis, and then change. Okay, you can change perform analysis and change. You can copy here and put it for the other 3 seismic loading. Okay, then enter and then paste, then put it here and then enter, then paste. Okay, then save it. Okay. If you go to the definition, now you can see that all the dead load, okay, all the dead load, and 25% of the live load has been added here. So software will automatically calculate seismic weight from your defined data. Okay. So this is the specification. How you can get your SS, S1, okay, R, RX, RZ, site class depend on soil type, okay, FA, FV, okay, and then the main issue is the period, okay, period along Z X direction and period along X direction and period along Z direction, okay. So this is how your definition, seismic definition, and you have also assigned the load case, okay. Always remember that for Stadd Pro, you have to first assign seismic load case. Okay, then you can put other cases. Okay, so first of all, always keep that mind. Always you will have to put earthquake load cases. Then you can dead load, live load as per your choice. But seismic load case will be always at the first. Okay, so here you can see our seismic load cases are 1, 2, 3, 4. Then we are dead load, live load, whatever the rest of the load we have, then we will put our wind load, So this is how we can, assign seismic definition and seismic load case. Okay. And we can also put the value of, seismic weight. Okay. From this data, software will automatically calculate W and calculate your base shear. Okay. I hope you like the video, and this is a very important lesson, because definition of earthquake is very difficult in Stadd Pro. So this is easiest way. Okay, this is the easiest way. There is another method, but that one is based, which is laborious. Okay, so this one is easier one to assign the W. So you can now check it and practice yourself. I hope you like the video. If you like the video, please do subscribe and keep watching. Thank you.